Hello, welcome to Bodhi Academy. Myself Bhumit, and today we will discuss the board question from the differential equation chapter. First of all, we will solve some 1 mark question from the previous year board examination. So first of all, how in this video we will learn how to form the differential equation if there's any solution is given. So let's start with the question number 1. That is of 1 marks and MCQ type. So what is given in the first question? Y is equal to 5e raised to x plus 2e raised to minus x plus x. Okay. So we have to find out what is the differential equation of this solution. Solution is already given. So what is the differential equation corresponding to this solution that we have to identify out of this 4 option. Okay. So the easiest way what we can do, take the derivative. Let's take the derivative of this y first of all. So derivative of y we can take one order. So y derivative of y is y dash is equal to 5 as it is, derivative of e raised to x, that we know that it is e raised to x only, plus 2 as it is, and derivative of e raised to minus x, that is we know that it is e raised to minus x, and then after that derivative of minus x, that is minus 1, plus derivative of x is 1. Okay. Let's take the derivative one more time, because in all the options we have the second order derivative. So derivative of y dash, that is y double dash, okay, that is also nothing but d square y by dx square is equal to 5 as it is, again derivative of e raised to x, that is e raised to x, then plus 2 as it is, derivative of e raised to minus x, that is e raised to minus x, okay, and derivative of minus x, that is minus 1, and one more minus 1 is there, okay, and plus derivative of 1, that is 0. So if you can see that here this 5 e raised to x as it is, plus 2 e raised to minus x, that is also as it is, this minus 1 become plus 1, and then plus 0. Okay, so if you can see here, y double dash is equal to, we are getting 5 e raised to x plus 2 e raised to minus x. So we will find the value of this 5 e raised to x plus 2 e raised to minus x from the, let's say this is equation number 1. So from the equation number 1, okay, if I take this 5 e raised to x, we want to find out the value of 5 raised to x plus 2 raised to minus x. So if you take this x in the left hand side, that means it becomes y minus x is equal to 5 e raised to x plus 2 e raised to minus x. Okay, so from the equation number 1 we can say the value of 5 e raised to x plus 2 e raised to minus x is nothing but y minus x. So we can substitute here, in place of 5 e raised to x plus 2 e raised to minus x, it is y minus x. Okay, so now look at in the option, which option is satisfying. Y double dash, that means d square y upon dx square. Okay. If we take this minus x, this side will become plus x is equal to y. Okay, so each option is satisfying. First one is saying d square y by dx square, that is correct. After the second is dy by dx, that is wrong. Okay, so first option is wrong, second is satisfying. Okay, so second is our correct answer. Now look at the question number 2. That is the simple one based on the degree and order. The question number 2 is, what is the degree of the differential equation? And differential equation is given d square y by dx square, that means y double dash we can write down, okay, raised to power we can write down 1, plus 4 dy by dx, that means y dash, okay, no need to write down, you can identify directly also, is equal to x raised to 4. So the question is degree. Okay, first of all, tell me what is the order. If we say, if the question is what is the order, then the highest order derivative present in this equation is 2. So order become 2. Now what is the degree? In this question we need degree. So degree means what is the order. Okay, order is 2. So what is the power of that? Power is 1. Okay, so degree is 1. So for this question, the answer of the degree is 1. So option number D is correct. Order is 2 and degree is 1. Now look at the question number 3. So in the question number 3, the integrating factor of dy by dx plus y upon x is equal to x square. So we need to find out the integrating factor. So first of all, we have the equation dy by dx plus y by x is equal to x square. So I will write the result first of all. If the equation is like this, dy upon dx plus p of x into y is equal to q of x. If the differential equation is given in this form, then what is the integrating factor of that equation? Is nothing but e raised to integration p of x dx. This is the integrating factor. Okay, and in this question we have to find out only integrating factor only. Okay, so it is already given in this form, only dy by dx plus p of x. Now what is p of x in this question? Second term it is given to be y upon x. Okay, so this we can write down as 1 upon x into y, okay, is equal to q of x. Q of x means in the right hand side we need the term in terms of x, so it is x square only. Okay, so what is the p of x? If you match these two equations, the value of p of x is nothing but 1 upon x. Okay, this is our p of x into y. So p of x, the value of p of x is 1 upon x. So we need to find out integrating factor. So we have the formula e raised to integration of p of x dx. So integration p of x, so p of x is 1 upon x dx. So e raised to power integration of 1 upon x now. So integration of 1 upon x, we know that it is nothing but log x. Okay, and we know that e raised to log, that is nothing but e and log, we can cancel out, so answer is x. So for this question also the answer is B, option number B. Okay, and remember this e raised to, suppose we are getting log of sine x, then answer is sine x. Okay, we can cancel out this e and log. Now look at the question number 4, that is of the degree and order. Okay, so the question is 1 plus dy by dx, that means we can say it is y dash raised to power 2 and whole raised to power 3 by 2 is equal to 5, and this side it is going to be y double dash. So in this question we cannot find out the degree and order directly, because here fractional power is given. So we have to remove this fraction first of all, fractional power. So 3 by 2 is there, so we can write down that 3 by 2 as 1 plus y dash raised to power 2 raised to power 3 by 2 means we can write down as 3 into 1 by 2. So the fraction power is 1 by 2 only. Okay, so we have to remove this 1 by 2. So if you take on both the side square on both the side, if we take the square on both the side, what we will get? This 2 and this 2 will get cancelled, so what will remain? 1 plus y dash the whole square raised to power 3 is equal to, if we take the square here, it becomes 25 into y double dash the whole square. Okay, so now we can find out what is the degree and order. So what is the highest derivative present in this equation? So highest derivative is y double dash, that means order is 2. What is the power of that? 2. So degree is also 2 in this question. So order is 2 and degree is also 2 for this differential equation. Come to the next question. So for this question the option number D is correct. Okay, now this question is very important in your board exam. You will get this type of question, that form the differential equation, one of them family of curve or solution will be given. Okay, so in this question y is equal to given e raised to x a, here it is cos x, a into cos x plus b into sin x. Okay, so first of all you must know that whatever arbitrary constant are present in the solution or any curve, that order differential equation we will get. So in this family of curve we have two constant a and b. Okay, so we will get the differential equation of order 2. Okay, remember this result, number of arbitrary constants is equal to order of differential equation. So in this equation we have two arbitrary constant, so we will get the differential equation of order 2. Okay, so take the derivative one time first of all. So derivative of y is y dash is equal to, now in the right hand side we have to apply UV rule because it is in multiplication. So let's take this e raised to x as u, and this remaining part is v. So we know that what is the uv rule? Derivative of uv, u as it is derivative of v plus v as it is derivative of u. Okay, so if we apply here, so first of all let's e raised to x as it is derivative of v. Okay, so derivative of v means a as it is derivative of cos x, that is minus sin x, plus b as it is derivative of sin x, that is cos x. Okay. Now take the derivative one more time. So derivative of y dash, that is y double dash, is equal to, okay, sorry, this uv rule is not done. No? So in the last step, u we have taken as it is derivative of v, now plus, now the second time we have to take v as it is. Now v as it is, v means a cos x plus b sin x into derivative of u. So u is e raised to x, and we know that derivative of e raised to x is e raised to x only. Okay. Now take the derivative one more time. So derivative of y dash, that is y double dash, is equal to, okay. Now before taking that second derivative, what you can see here, we will write this y dash, this e raised to x as it is in this bracket, a into minus sin x, that we can write down as minus a sin x plus b cos x plus, now look at the second term, a cos x plus b sin x into e raised to x, that is nothing but the value of a e raised to x, a cos x plus b sin x is nothing but, it is the value of nothing but y. So in place of this second term we can write down as y. Okay. So in the next step we can do the derivative easily. Okay, now we will take the derivative again. So derivative of y dash, that is y double dash, is equal to, now here again we have to take the uv rule. So e raised to x as it is derivative of this bracket, that is minus a derivative of sin x, that is cos x, plus b as it is derivative of cos x, that is minus sin x. Okay. Then plus the second time we will take the bracket as it is, that means minus a sin x plus b cos x, and derivative of e raised to x, that is e raised to x, then plus derivative of y dash, that is sorry y, that is y dash. Okay. So now if we solve further, this e raised to x as it is, so in both the term inside the bracket we have minus sign, so if we take minus sign common, what will remain inside the bracket? A cos x plus b into sin x plus this term as it is e raised to x into minus a sin x plus b cos x into e raised to x we have written plus y dash. Okay. Now you can see that this minus e raised to x as it is, okay, not to write down e raised to x. So from the, let's say this is an equation number 1. So what is y? The value of y, e raised to x, a cos x plus b sin x. So we have exactly this thing is here, e raised to x cos a cos x plus b sin x, that means this is nothing but y, so it become minus y, then plus, now we have to find out the value of e raised to x into minus a sin x plus b cos x. So you can see that that is in the second equation, let's say this is an equation number 2. Okay, so from here we can find out what is the value of this term if we take this y that side. Okay, so we'll get y dash minus y is equal to e raised to x inside the bracket minus a sin x plus b cos x. Okay. So the value of this term is nothing but y dash minus y. So we can put it here, y dash minus y. Then plus the last term, that is y dash as it is. In the left hand side we have y double dash. Okay, so we are done more almost. Y double dash, so here is equal to minus y, that is minus 2y, and y dash plus y dash, that is plus 2y dash. So we take on both the term left hand side, so y double dash then minus 2y dash plus 2y is equal to 0. So this is our required differential equation. Okay. Okay. Move to the next question. Again the same type. One differential, we have to form the differential equation by eliminating arbitrary constant. So in this equation we have only one constant. Okay. So we will get the differential equation of order 1. Okay. So equation is given x minus a the whole square minus y square is equal to 1. So let's take the derivative one time first of all. So derivative of x minus a the whole square, that is nothing but 2 times x minus a raised to power 1. Okay, one power will reduce, one power become then derivative of x minus a, that is 1 only. Derivative of x is 1, derivative of minus a is 0, minus derivative of y square, that is 2y, and then derivative of y is y dash. Okay, is equal to derivative of 1 is 0. Okay, so from now what we can do, okay, let's solve 2 into x minus a. Let's take this term that side, so it will become 2y y dash, and then from both the side we can cancel out 2 and 2. So what is the value of x minus a? We can say the value of x minus a is nothing but y into y dash. Let's say this is equation number 1, this is equation number 2. So we can substitute the value of x minus a, that is y dash, in the equation number 1. Okay, so if we substitute in the equation number 1 the value of x minus a, that is y into y dash raised to power square. Okay, this we have kept here. So y into y dash the whole square minus y square is equal to 1. Okay. So if we apply the square, so it is nothing but y square into y dash square minus y square is equal to 1. So this is our required differential equation. Okay. So there is no arbitrary constant now, and you can see that it is the differential equation of order 1. So this is the answer. Before solving this question, we will solve the same type, this form the differential equation. Okay, look at this question first. It is given that y is equal to a cos 4x plus b sin 4x. So in this equation you can see that we have two arbitrary constant a and b. That means in this, for this equation we will get second order differential equation. Okay, so let's take the derivative first time. So derivative of y, that is y dash, is equal to a as it is, derivative of cos 4x, that is minus sin 4x, and derivative of 4x is 4. Don't forget to take the derivative of 4x, that is 4, plus b as it is, derivative of sin x, that is cos 4x, again derivative of 4x, that is multiplied by 4. Now let's take the derivative one more time. So derivative of y dash, that is y double dash, is equal to minus a as it is, derivative of sin x now, that is sin 4x, that is cos 4x, and derivative of 4x is 4. And remember that one more 4 is already there, so one more 4, that is multiplied by 4, plus b as it is, derivative of cos 4x, that is minus sin 4x, and derivative of 4x, that is 4, and one more 4 is there, so multiply by 4. Okay. Now let's simplify. So minus a cos 4x into 4 into 4 16, this plus into minus, that is minus b sin 4x into 4 into 4, that is 16. Okay, so now in both the term we can take minus 16 outside common. So if you take minus 16 common, what will remain is a bracket a cos 4x plus b sin 4x. So let's say this is an equation number 1. So you can see that a cos 4x plus b sin 4x, that is nothing but the value of y. So you can put it here, y double dash is equal to minus 16 into this is nothing but y. So if we take in the left hand side, so y double dash plus 16y is equal to 0. This is our required differential equation. Okay. Now look at the question number, next one, that is 6. Now, in this question also we have to form a differential equation. Arbitrary constants are a and b. Okay, so we will get the second order differential equation. So it is given y square is equal to a inside the bracket b square minus x square. Okay, so if we multiply this a inside, we will get ab square minus ax square. Y square is equal to. Now we will take the derivative. So derivative of y square, that is 2y, and derivative of y is y dash, is equal to, this is the full constant term ab square, so derivative of that constant term is 0, minus a as it is, derivative of x square, that is 2x. Okay, so what we will get with this, we can write down minus 2ax, 2y, y dash is equal to. So from both the side we can cancel out 2, and we can find out the value of a from here. Okay, so we want to write down the value of a, that is nothing, okay, minus a. What is the value of minus a? It is nothing but y dash upon x. Okay, this is the value of minus a that we will require in the, okay, you will get. This is the first order. Let's say this is an equation number 1 and this is 2. So equation number 1 is y dash is equal to minus ax. So take the derivative one more time. Okay, so in the left hand side, now for the derivative we have to apply UV rule. Okay, here y into y dash is there, so we'll apply the UV rule. So first time y as it is, derivative of y dash, that is y double dash, plus second time y dash as it is, and derivative of y, that is y dash, okay, is equal to, what is the derivative of minus ax, that is minus a, derivative of x is 1. Okay. So in this, now we need the value of minus a, that is from the second equation, what is the value of minus a by y dash upon x, that we will put it here. So y dash upon x. In the left hand side, y double dash plus y dash into y dash, that is y dash square. Now if we multiply throughout by x, what we will get? X y double dash plus x into y dash square is equal to, here x and x will get cancelled, so y dash. This equation also you can write down like this: x into y double dash means d square y upon dx square, plus x, y dash means dy upon dx, the whole square, is equal to y dash means dy upon dx. You can take this term this side is equal to, equal to 0 also. So this is the answer. Come to the next question. But this question is interesting. Again, y is given, we have to form the differential equation. You can see that two arbitrary constants are there, a and b, and a e raised to x and b e raised to minus 3x. Now here the numbers are not equal. If the numbers are equal, in the coefficient of x are equal, then it is easy to solve. Okay. Now see here how to solve this. So y is given a e raised to x plus b e raised to minus 3x. We have two arbitrary constants, so we will get second order differential equation. Okay, so let's take the derivative one time. So derivative of y, that is y dash, is equal to derivative of a e raised to x is a e raised to x only, plus b as it is, derivative of e raised to minus 3x, that is e raised to minus 3x, and derivative of minus 3x, that is minus 3. Okay, so we can write down this as a raised to x minus 3b e raised to minus 3x. Okay, y dash is equal to. Now we will simplify this y dash. Now see, a e raised to x, this minus 3b e raised to minus 3x, this we can write down like this, plus b e raised to minus 3x minus 4b e raised to minus 3x. What we have done, just there is minus 3 we can write down as 1 minus 4. Okay, what we have done, minus 3 we have written 1 minus 4. Okay, 1 minus 4 means minus 3. So here it is minus 3b e raised to minus 3x. So we have written 1b e raised to minus 3x minus 4b e raised to minus 3x. That is the same thing. Okay, why we written like this? To make y dash. Now you can see that a e raised to x plus b e raised to minus 3x, that is nothing but our y actually. Okay, so in this place we can write down as y minus 4b e raised to minus 3x. Okay. Now take the derivative one more time. So y dash is equal to, we have y minus 4b e raised to minus 3x. So if you take the derivative one more time, so we will get derivative y dash, that is y double dash, is equal to derivative y, that is y dash, minus 4b as it is, and derivative of e raised to minus 3x. It's better to take okay, let's continue. E raised to minus 3x and derivative of minus 3x, that is minus 3. Okay, so what we will get, y dash, this minus minus become plus 12b e raised to minus 3x. Okay, y double dash is equal to, we are getting y dash plus 12b e raised to minus 3x. Now we have to eliminate this b from here. So from here we can find the value of b from here. So if we solve this further, let's say this is star, so y dash, if we take this y, that side become minus y is equal to minus 4b e raised to minus 3x. Okay. So if we take this minus 4 in the denominator, we will get y dash minus y upon minus 4 is equal to b e raised to minus 3x. Okay, so we got the value of b e raised to minus 3x, that is y dash minus y upon minus 4. So that value we will substitute here. So y double dash is equal to y dash plus 12 as it is, the value of b e raised to minus 3x, that is y dash minus y upon minus 4. Okay, so now b we have eliminated, so we have to just simplify only. So y double dash is equal to y dash, this 4 3s are 12, and this plus minus become minus y dash, that minus minus become plus y. Okay, so take this all, okay, here y dash and minus y dash, that will get cancelled, so only plus y will remain. Okay, it is correct. Y dash, this become minus of y dash minus y, so y dash, if we multiply minus and inside, so minus y dash minus minus plus y, yeah, correct. So y dash will get cancelled, so y double dash is equal to, we are getting y, if we take that side, it becomes y double dash minus y is equal to 0. This is our required differential equation. Okay, now look at the next question. Again y is equal to, given what we have, a e raised to x plus b e raised to minus x plus x square. So in this differential equation also you can see that we have two arbitrary constants, so we'll get the second order differential equation. So let's take the derivative first time, or before that, okay, now let's take the derivative first time. So derivative y, that is y dash, is equal to a as it is e raised to x, derivative of e raised to x, that is e raised to x only, plus b as it is derivative of e raised to minus x, that is e raised to minus x into minus 1, plus derivative of x square, that is 2x. Let's take the derivative one more time. So derivative of y dash, that is y double dash, is equal to a derivative of e raised to x, that is e raised to x, plus b as it is e raised to minus x, derivative of e raised to minus x is e raised to minus x, and derivative of minus x is minus 1, and one more minus 1 is there, so that is also as it is, plus derivative of 2x, that is 2. So y double dash is equal to a e raised to x, this minus 1 into minus 1, that is plus b e raised to minus x plus 2. Okay, but now we have to eliminate this constant arbitrary a and b, so we'll use the equation number, let's say this is equation number 1. So from equation number 1, what is the value of a e raised to x plus b raised to x? So if we take this x square in the left hand side, so y minus, we will get x square is equal to a e raised to x plus b e raised to minus x. Okay, so the value of a e raised to x, b e raised to minus x is nothing but y minus x square, that we will substitute here. So y double dash is equal to a e raised to x plus b e raised to minus x, that is nothing but y minus x square plus 2. Okay, so if we take all this term that side, y double dash minus y plus x square minus 2 is equal to 0. So this is our differential equation. Also we can write down like this: d square y upon dx square minus y plus x square minus 2 is equal to 0. Okay, so this is the question, that is how to form the differential equation whenever solution or any family of curve is given. Now let's solve two questions of variable separable form. Okay, so dy upon dx is given e raised to x minus y plus x square into e raised to minus y. So this is variable separable. How to identify? So we can separate the value term of x and y, then it is variable separable. So dy upon dx is equal to, given that e raised to x minus y, so this we can write down as e raised to x into e raised to minus y, plus the second term is x square into e raised to minus y. Okay, so from both this term we can see that e raised to minus y we can take common. So if we take e raised to minus 1 common, what will remain inside the bracket? E raised to x plus x square. Okay, so this is the term of x only and this is term of y. So if we take this e raised to minus y in the denominator, and we can take this this dx that side, so we'll get dy upon e raised to minus y is equal to e raised to x plus x square into dx. Okay, so x term we have taken with dx, y term we have taken with dy, and this e raised to minus y if we take in the numerator, it become e raised to plus y dy is equal to e raised to x plus x square into dx. So it is a variable separable, integrating both the side now. So if we integrating on both the side, integrate both the side, what will get? Integration of e raised to y dy is equal to integration of e raised to x plus x square dx. So all you know that integration of e raised to y, that is nothing but e raised to y is equal to, here integration of e raised to x is integration e raised to x only, plus integration of x square. Okay, that is not 2x, remember that it is an integration, not derivative. So integration of x square is x raised to 3 upon 3 plus c. So this is our final answer. Come to the next question. So again this is also variable separable. What is given? dy upon dx is equal to xy plus x plus y plus 1. Okay, so from the first two term you can see that x we can take common. So if we take x common, what will remain inside the bracket? Y plus 1. In the second two term, if we take plus, nothing is common, so we can take plus, always 1 common. So inside the bracket y plus 1 remain, y plus 1. Now in both the term y plus 1 is common again, so we can take y plus 1 common. So in second bracket we will get x plus 1. Okay, so x term is separate, y term is separate, so we can separate the with dy with x term, dy with y term and dx with x term. So if we take this y plus 1 in the denominator, so dy upon y plus 1 is equal to this x plus 1 into dx. So x term with dx, y term with dy. So now it is variable separable, so we can take integration on both the side. Okay, so if we take integration on both the sides, so dy upon y plus 1 is equal to integration of x plus 1 into dx. So we know that integration of 1 upon y plus 1, that is nothing but log of y plus 1 is equal to integration of x, that is nothing but x square upon 2 plus integration of 1, that is x plus c. So this is our answer. Okay. So this is the previous year board question paper. We will get the question on order and degree from this chapter, as well as how to form the differential equation and how to solve the general solution of the any differential equation. Okay, so we'll stop here. Thank you everyone, and if you are liked our video, then please subscribe.